All right, here's part 3 to our factorial ANOVA about rat smoothies and their rat push-ups. Here's the data. Doing an ANOVA, commonly called an analysis of variance. And it's a two-way factorial. So now we're going to start working on the bracket terms. Okay, there's a one-way ANOVA table. Bracket terms over here. That's where all your math is. But remember, this is simply a one-way table. We need to switch to the two-way table. And there it is. So let's just start with the between groups of the first factor. Right, that's going to be our factor A. It's always the between groups. Y is our within group variance, right? That's also your error term. And T stands for total group variance. But now with a two-way ANOVA, we have more than one factor. So now we're going to add a different symbol. We're just going to call it B. Okay, bracket term B just means for the other factor, for the other IV. And the new B to the block, you know, your worst nightmare, is the AB interaction bracket term. It's really not that bad. You're just going to do some manipulations with the data and come up with a solid number that you're going to plug into the source table. Okay, let's start with A. If you could see this little thing, there's the formula in the top row, between groups, bracket terms. Okay. Let me make it big for you. So what this means is we're going to sum up each individual group of J after we square it, and whatever that sum is, we're going to divide it by the product of the number of levels of B times the number of individual rats in one single group. That's what the little n stands for. Just remember this. J normally talks about a group sum or a column sum. In other words, one specific group that sum is. And this, a lot of teachers call them group sums, but they have to be the individual groups, or if it's a total group within group, right? The groups change depending on what type of bracket term you're trying to solve there. But then you just add up everybody in the group and then you square it. And the sigma here just means it's just a giant plus sign. It means after you do that to all the groups, you just add up their values, and then you're going to divide whatever that total is by the product of B times N. So let's go ahead and find the sum of each group, right? A1, B1, when you add them all up, is 90, and I will use the power of technology. And so there's all the sums of each of the individual treatment groups. So now we're just going to break it down into the levels of A, which were, right, no milligrams, 10 milligrams, 20 milligrams, or commonly called A1, A2, A3. So to find A1, we need to add A1 at B1 and A1 at B2, right? There's two separate levels there. And the same thing for A2. We need A2 at B1 and A2 at B2. In other words, so A2 is the 10 milligram rats at the small smoothie and the 10 milligram rats at the large smoothie. And this can get kind of daunting, okay? It's easy to make a mistake here, but just try to keep this stuff straight in your head. And this represents the 20 milligrams small smoothie, 20 milligrams large smoothie. We're going to add those up, and then we're going to square them, right? So here's our A1 group. There's our A2 group, and there's our A3 group, regardless of the smoothie, okay? Regardless of the smoothie size. This is our A, factor A, between group variance formula. So let's go ahead and there's our factor A, and now we're going to add the A1s together and we're going to square them. And that's going to be our column J if we just put all the A1s in one long column, regardless of the, you know, the B1 or the B2. We're just going to add them all up and square them. Do the same thing for the 10 milligram group, right? The A2 group. We're going to add them up and square them. And then the same thing for the A3 group. We're going to add them up and square them. We're going to do a little bit of math. Oh, well, okay, this is what's going on. So the 147, that is the total of everybody in A1, regardless of whether they're in B1 or B2. We add all those up and we square them. Same thing for A2, same thing for A3. So now let's do a little bit of math. And we're going to get that number, but we still need to divide that by B and N, B times N. And B, as you recall, is the number of levels of the B factor. So the B factor is the smoothie size. So there's only large and small, so it means there's 2 levels for B, right? And then N is how many rats in one single treatment group. The little n means how many in one single group. 1, 2, 3, 4, 5, 6. So little n is 6. Okay, so we just plug and chug. 2 times 6 is 12. 54409 divided by 12 is, bam. So that is our A bracket term. Now we have to repeat this process about 5 or 6 times using minorly different formulas, but I'm going to walk you through this one at a time. So this A bracket term represents the variance between groups A1, A2, and A3. Okay, it represents the variance, in a manner speaking, between the groups formed by the serum, by A. Okay, between group variance. This is what you're going to try to prove is significantly different. So factor A, strength serum, did that by itself have any significant difference with the number of push-ups these rat heads were doing? Right, the different levels. A1, was there a significant difference between A1, A2, and A3, regardless of the small or large smoothie thing? And that's it for part 3. MGZ, out of here.